Hey everybody, Lars here. This is the first video for Unit 1. It's really also the first review video you're getting, so I'm going to go over some simple stuff today and basically help you get your sea legs and help you do some simple coding so you can understand pretty much the first half of the slides. The first thing we're going to do is I'm going to fire up idle. I'm assuming you've been to the python.org page and you've downloaded a recent version and you got it running on your machine. As you can see by looking at the screen, I've got a Windows box here. I got a whole bunch of different Pythons. I'm going to fire up idle. We use idle in this course. Later on, when you're done learning, you can go off and use Wing IDE or Anaconda or whatever your heart desires. But right now, I go with idle. I don't want the integrated development environment to get in the way when we teach, so I just want to do some simple stuff. So basically, all I did was I fired up the interactive window, and real quick, just to show you the interactive window, we can assign a variable. So I say A is assigned 3, and I can say B is assigned 7, and then if I want to look and see what those variables are, I can go A is that, B is that. I can do simple arithmetic like that, and we can do it just like a calculator. We can do different calculations and different things here at the interactive window. As you can probably see, Python is dynamically typed, so it guesses what things are. If let's say I said D 7.77, and I said D, that's a floating point number versus an integer. I can use the type function on A, and it says class int, and it tells me it's an integer. If I use type on D, then it'll come back and tell me it's a floating point number because it has numbers after the decimal. So when you give a value to a Python variable, it's going to make its best guess on what you're doing. Basically, if you give it a number without anything after the decimal, it's going to say you're an integer. That said, I'll use this E here. If I give it 5.0, it's going to know that I want it to be a float because I gave it something, even though it's a 0, I gave it something after the decimal, so it does save that as a float. I can even take my name and save that in a variable. That is a string. In programming, when you have a word or something saved, it's called a string. It's a string of characters that gets laid out. So we could play around, and later on you're going to see we're going to come back and look at the interactive window as far as debugging is concerned. We can do a whole bunch of things here at the interactive window, but what we really want to do is create a program, because a program, a file of code off on its own, we can get rid of, shut down our computer, go to bed, walk the dog, take out the garbage, do whatever your heart desires, and the next day when you get up, you can load that program back and start where you left off. It's a permanent store of your logic, if you will, or what you're putting down in your program. So the way we're going to do that is I'm going to hit File, and then I'm going to say New, and I'm going to get a blank window here. A lot of times in Python books or different Python resources, you'll see they don't really use the word program. They'll call it a module. So when you have a separate little piece of code, sometimes it's called a Python module. I call it a program, module, file, same old, same old. When I do that number sign, I am creating a comment. I'll say this, hey, this is a comment. And basically I'll just put my name in there. Let's see. I'll say author. Hey, how about spelling that right? I'll say author Lars, good enough. Okay. And the first thing we're going to do, because we're duty bound, is I'm going to print hello world. Now, I don't know. Since the beginning of programming, whenever you learn your first, not your first, but whenever you learn a language, the first thing you do with it is you print hello world to the screen. So we're going to do that right there. But it's going to be illustratives because I just showed you how to get that window. We typed up some code. Now I got to do two things before I can run the code. I've got to save it. So I'm going to say save as, and I'm going to go to, did I save something for this? I don't know. Data, Python, data, fall 2018, which is when I'm doing this, and I am going to just call this rev1. So I'll call the file rev1. So now I've saved it. So now what I want to do is run it. So I come up here, I say run and run module. I click F5, and then The run of my program is down here in the interactive window. You can see it printed right there. Hello world. Okay? So the two things you want to do when you run your code is save it. And as you can see, because we're going to start doing this, save or Control S, and then run module or F5. Remember, this isn't always called a program. Sometimes this is called a module. So run module, you say F5, boom, and it runs it, and it prints hello world to the screen. So we've gone ahead and pulled that off. Now, if I want to get rid of this, I can just comment it out, and everything after the number sign is ignored when we run the program. If I rerun, it goes bloop. Now, you just saw me run the program without clicking any buttons up here and saving and then running. It's because what I'm doing is I'm doing Control S, and then I'm doing F5. And if you look down, you can see Control S, F5. It kind of makes a diagonal up the keyboard. When you're a Python programmer, you're going to learn how to do that in your sleep. You just got to, it's just going to run. So a lot of times when you watch these videos, you're just going to see it run. And you're going to think, what's he doing? Is he doing some kind of trick? It's no trick. Control S, F5. All right? All right. So let's get some variables. I'm going to say num1, and I'm going to assign it the value 7. And then I'm going to say num2, and I'm going to assign it the value 17. Okay? Now, let's do some stuff. I say the sum and not sum. I will tell you why in a minute. And I will say that is num1 plus num2. What excitement. I will say the diff. And I will say num2, because I don't feel like playing with negatives. Num1, and then I will say product is num1 times num2. We're crazy now. Then I will say quotient. And I will assign that the value of num2, 1, 2, num1. You might be saying what's going on there. I'm going to show you in a second. There's a second time kind of quotient, and that's going to be num2, num1 with only 1 /. Okay, okay, we got some good things there. I'm going to do print, and then I'm going to show you for the first time how we print variables. You just put it in and then comma. You don't have to put things in quotes. That's what you want to do with strings, like we did with hello world. Those are things called string literals. Right here, we're going to print out some variables. So I say the diff, the sum, I'll say prod, I'll say quote, and quote 2. Okay? And then when we run Control S, F5, you'll see, let me separate out this so we can see. We get 24, which is indeed the sum, 10, which is the difference, 119, which is the product, and then we get two different numbers for our quotients, and I think by looking at them you can guess what's going on here. The first one is a 2, and the second one is 2.4284. Okay? The first one, the doubles, is what's called integer division. Okay? Integer division always rounds down. That goes to the floor. You have a floor, you have a ceiling when it comes to rounding numbers. Okay? Integer division always goes to the floor. So it's always going to be whatever that number is without the decimal portion. So when we do that first one with the 2 slashes, we get integer division, which is just 2. But if we do it with 1, we get quote 2. And because we did that and we got that right there, you can see right here, I'll print it out. I'm going to print type quote 2, and we're going to see that it's a float. Okay, class float, because that's a floating point number. If we did the same thing with the first quote, well, actually, I'm going to show you. We do the same thing with the first one. Am I balanced there? Yeah, I'm balanced, but I better spell type right. Now we look, you'll see the second one's an integer, because it's integer division. So the operation returns an integer and puts it in that variable right there. Okay? All right, we got 2 little extra things we want to do. I'm going to take a variable called SQU, called squoo, and I'm going to say num1, bang, bang, 2. And then I'm going to do another one. I'm going to call it remained, and I'm going to, what's that about? I'm going to say that num2 %, num1. Now I'm going to print me squoo and remains. So when I do this, I get 49 and 3. So let's figure that out. First of all, num1, bang, bang, 2, apostrophe, apostrophe. That my friends, is exponentiation. I don't have to use a 2. I could have put a 3 there or a 4 there, but I put a 2, so I squared num1. So num1 is 7. 7 by 7, 49. Okay? I could have cubed it. I could have done anything. 1, 2, that's exponentiation, which makes sense because multiplication is what? It's addition on steroids. So what is exponentiation? It's multiplication on steroids. So instead of 1 apostrophe like we have with multiplication, you have 2. Okay? So it kind of makes logical sense there. Now, this one right here, as I have said many times before, is the worst named operator in the history of operators because that is modulus or modulo, but it should be called the remainder operator. Okay? Because that's what it does. It gives you the remainder of division operations. So if you look at our two terms up there, 17 modulo 7, do the division. It's 7. It goes into 17 2 times clean with the 14, but then you have 3 left over. What do you get? 3. Modulus gives you the remainder. And you might be thinking right now, oh, what a nifty little parlor trick that is. How wonderful. I'll bet you I'll never used it. You are going to be shocked at how often you use modulus. That's why we go over it right now. We let you in on it. Modulus is good for seeing if something divides evenly into something, because then your modulus will be 0. And you would be shocked in how many operations, especially in number theory and factoring and the different things we're going to do in data science and computer science. Excuse me, the coffee break is now here. Oh, that is good. I am exhausted. All right. Modulus comes in handy all the time. So you need to know about it. You need to see what's going on. All right? All right. Now, this program right here, and if you can see, we haven't been going very long, but we already have a decent little hunk of code right here. Could get pretty boring pretty quick, though, because we know all of the arithmetic relations between 7 and 17 now, but that's really all this program does. Okay? What if I wanted to create a program where when I ran it, it would ask for the numbers? So I could do any numbers I wanted. Okay? I'm going to show you exactly how we do that. And then I'm going to show you a little trick. I'm going to say num1. Take these glasses off. And I'm going to assign it to this. Enter a number. And that, and that, and that. And then down here, I'm literally going to copy and then paste. Why did that happen? Do I have an undo? I do. There we go. And I'll just say enter a second number. Okay? So what's going to happen here is I'm going to run the input function, and it's just going to put that string literal out in front, kind of as a prompt, and I can then do something afterwards. Actually thinking about that now, give myself a space there so it looks good. And then when I enter the number, it's going to be placed in these variables. But as you can see, why am I wrapping it in that int? You're going to see that in a moment. First, let me run the code. I'm going to save. Don't have to do that kind of save because I already did it. F5 to run. It says enter a number. Well, I know what the values are for 7 and 17, so why don't we just do that again? I'll give it a 7. I'll give this a 17. And look at that. I get the same numbers that I did above. So I think I'm in pretty good shape here. But the reason I wrote it is because what if I want to try some other things? I'll give it a 10. I'll give it a 24. Now all of a sudden I've got some different numbers. Okay? And because I know what's going on here, 10 squared is 100. 24 divided by 10 goes in evenly twice. The remainder is 4. Look at that. The modulus is 4. So now I'm seeing the arithmetic relations for some other numbers. But in way of explanation, let me get rid of that little int there and see what happens when we run the code now. Enter a number. Okay, I'll give it a 10. Enter a number. Pretty good shape, 24. So now, oh, dum, 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 dum. See that nasty red? That's a Python error. Okay? And that's telling me, if you look down here at the bottom, unsupported operand type for str and str. And I don't know if I understand all that right off the bat, but once you get a little experience under your belt, you're going to figure out that Unsupported operand type means I'm trying to do arithmetic on a word, and that's not allowed. You're going to learn that the input function returns a string. It returns characters. It returns a word. And then all of a sudden you try to do math on those words and you can't. Okay? Remember when I said we could use the interactive window to troubleshoot? I can do a type on num1 and it's going to come back and tell me it's a string. And then I'm like, oh, okay, now I get it. Because if we type num1, look at it. It's surrounded by quotations. It's a string because that's what input returns. So what I want to do is I want to tell Python, hey, whatever you get from that input, make it an integer. So that's why I put the int there. That's a function that makes whatever on the is on the inside into an integer. That operation in computer programming is called casting. I cast the string to an integer. I can take a float and make it an integer. I can take an integer and make it a float. Any integer, let's say 77, can be a float, 77.0. Okay? So you can move in between the different data types by using casting. Here, I'm going to give you a string, but that string is going to be a number. And later we can go into some error checking. But right here, just very simply, I want you to take that number and use it as an integer because I'm going to perform arithmetic. So when I put those things back, and now I give it my 10 again, and I give it my 24, I'm back in business. Okay? So what I'm going to do here is I'm going to get my print hello world back. You can see I have everything in the first column here. You're going to see this run, and it's going to say enter a number. I'll say 10, 24, and everything's good. If I take one thing and just move it in one, and I try to run this code, unexpected indent. Won't let me do it because Python depends on white space. Okay? You do code blocks with indentation. So you've got to be careful with your indenting. Here, I want to make sure everything starts in the first column because I don't really have any code blocks. You're going to see code blocks in the second video for Unit 1. All right? Right here, we just have a list of commands that go straight down. You'll notice that everyone starts in the first column because white space matters in Python. Okay? All right. That's the end of review video 1. Stay tuned for review video 2, and we're going to go over some other things that we go through in Unit 1, like Booleans, and then we're going to look a little bit at if-then and some decision structures and start adding more stuff to your Python toolkit. All right? All right. I'm out of here. You have a good night, and I'll talk to you soon. Bye.